We are now at 11C. In the next preview assignment in the next class, you're going to need to be able to evaluate negative exponents and the logistic curve equation. So let's start with looking at some negative exponents. And so you see we have a chart, we have some missing pieces and parts, but let's start looking for patterns. There are some expressions in exponential form, like 5 to the third power, 5 to the second power, 5 to the first power, and the pattern being that our exponent is going down by 1. The pattern continues from 1 to 0 to -1. So we have a pattern going that gets us down into our negative exponents. We have some blanks that we'll be able to fill in. So let's look at what is here. So looking at 5 squared. 5 squared is definitely 5 times 5, but it's really 1 times 5 times 5 to get us 25. Here's the expression expanded, and then here's our value written as a fraction. Well, we could write it as 25 over 1. 5 to the first power, that's like saying, well, we've got 1 5, and therefore it's 5, or as a fraction, it would be 5 over 1. This one's interesting, but notice what the pattern is with our 5s. 5 squared, we have 2 5s. 5 to the first, we have 1 5. 5 to the no, we have no 5s, but we still have a 1, and that's our answer. Anything to the 0 power is going to end up being 1. And then we do a crossover. And I probably am doing too much analysis here. I probably should be reading the questions. So I'll come back to that crossover, and I'm going to read question 1. If you have not already read questions 1 through 4, go ahead and read those and do those, and then come back and we'll do more of this together. Question number 1 says, describe a similarity between the process to calculate 5 squared. Let me get some more color here. To calculate 5 squared and 5 to the -2. So something that is similar is they both have 5 times 5. They both have, well, they both have 2 5s. We'll leave it there, not that they both have 5 times 5. That's something they have in common. Question 2, describe a difference between the processes to calculate 5 to the squared second power and 5 to the -2. Well, the process is we're going to take that 1 times the 5 times the 5, but in the negative, it's going to be 1 divided by 5 divided by 5. What is the relationship between the values of these two that we are looking at? Ultimately, 5 squared is 25, or 1 over 25, or 25 over 1, sorry. And here, we don't have the value listed. So, using our thoughts, using the processes, looking at this, if it's 1, well, it's a reciprocal. It's going to be 1 over 5 times 5. It's going to be 1 over 25. Whereas 5 squared is 25 over 1, 5 to the -2 is 1 over 25. Then question 4 says, fill in the expressions and values for those cells that are blank. So we have several cells that are blank. Why don't we go ahead and keep going this way? So 5 cubed would be 1 times 5 times 5 times 5, or 125, which is the same as 125 over 1, to write it as a fraction. Both answers are great. Going this direction, if I now have 5 to the -3, that's 1 divided by 5 divided by 5 divided by 5, or it's going to be 1 over 5 times 5 times 5, which is 1 over 125. Looking at our chart that we just completed and playing around just a little bit more with these negative exponents, question 5 asks, what is a shortcut for calculating 5 to the negative anything if we know what 5 to that anything is? looking back at like 5 cubed and 5 to the negative 3, this was 125, and this ended up being 1 over 125. So a shortcut, if you know this one, write its reciprocal, because then 5 to the whatever n, negative n that you're looking for, it's going to be its reciprocal. Evaluate, find a value for the following expressions and show your work. Leave your answers as a fraction. So there are multiple ways that we could calculate, starting with part A, multiple ways. It is always good to know how to do these calculations by hand, but in our class, you're going to have a scientific calculator. So one thing you can go ahead and do is punch in 3, and then you've got to already know which one of these buttons is your button to send the next number to the power. And then you're going to have to practice, because will you hit 4 and then a negative button, or will you hit your negative button first and then 4? So since that can be confusing, let's go ahead and work this out by hand, and then you can practice making that process work on your calculator. So as it said here, if I already know something to the something, okay, if I already know like 3 to the 4th power, well, then 3 to the negative 4 is going to be its reciprocal. I feel more comfortable calculating this because I've got 3 times 3 times 3 times 3, that's a 9 times a 9, 81. So then this answer would be 1 over 81. And when you go to calculate it, it's going to come up in decimal form. So depending on how your professor, I'm your professor, is going to want this answer written, then that's going to depend on the best way for you to work it. I'd like you to know how to do both. I would like for you to know what this means as a fraction, working it by hand, and then I'd like you to know how to put it in your calculator to know how to poke this process in there, punch it in, and get it to come out accurately. So I will go ahead and type in 1 divided by 81, and I get a value of tenths, hundredths, thousandths, 10,000ths would be 125 10,000ths. So I'm asking you to play around with your calculator and find out how to punch in this 3 to the negative 4. And then stick with the same calculator. Don't change it up. And so mine, I need to do 3, send it up, x to the y. And then when I hit my 4, then I'll hit my plus minus key. And what did I just get? 3, send it up, 4 to the negative. And I'm getting something very different. 1 minute, please. I never want to make mistakes in class or on video, but we have a mistake. I need to practice hitting clear a whole bunch more on my calculator. So I'm going to hit clear several times and now try this again. 1 divided by 81, and I'm getting a value of approximately 0.012344. This is really cool. 5, 6, not a 7, but it's an 8. So that means my 6 would go up to a 7. So somewhere in the approximate neighborhood of 0.012345.7. Now when I go to punch this in my calculator, I'll hit clear a whole bunch of times. I'm going to punch 3, then I punch x to the y, then I punch 4, and then I punch the plus minus key to make it negative. And when I hit equals, I get the same value. Decimal 0.12345.6, and then that 7 is going to make the 6 turn into a 7. Moving down to the next problem, we have this value. And so we've got a fraction and we got several things going on. I hope that one of the patterns you saw is whenever we were doing like 3 to the negative 4, one way to write it is 1 over, and whereas here we had 3 to the 4 is 3 times 3 times 3 times 3 times 3, here we would just write it over that, and then we would have the 1 over 81 and have the same value. That's how I'd like to solve this one, or to evaluate this one. So I'm going to put 1 over Well, it's 1/2 times 1/2. So we have 1 over, and when we multiply our fractions, it's top times top and denominator times denominator, which means in our denominator, we've got 1 over 4. We have to remember that when we're multiplying fractions, we will keep the numerator the same, change the division bar to multiplication, and multiply it by the reciprocal. So this one's getting a final answer of 4. And this would be a great one to practice putting in your calculator because you're going to need to either write 1/2 as a fraction or write it as 0.5. But I'm going to type in 1 divided by 2, and I get my 0.5, and I'm going to send it up to 2, which is negative, and it comes out 4. In your 1332 class, you're also going to be working with the logistic curve equation. And we're going to need to know how to find a value of this logistic curve equation accurately using our calculator. And it's going to require 2 skills. First, understanding where in the world do I put all of these values in the formula. And then second, once I get all those values in there, how in the world do I have the correct order of operations that are going to be needed to evaluate the resulting expression? Logistic curve equation is given by the formula you see here. You do not need to memorize this formula, but you do need to memorize these 2 things just mentioned. Understand how to put or where to put the values in the formula, and number 2, understand the correct order of operations that are going to be needed to evaluate this resulting expression. So notice the nice careful steps that we're about to go through. It says substitute these values into the equation, but do not simplify. I'm given an A, here's the A. I'm given a B, here's the B. I'm given C, there's a C. And I'm given an X, there's an X. So the only things I don't have a Y, and well, 1's 1, so there's nothing else to put in its place. So the first thing says substitute. So I'm going to write the whole entire formula. I'm going to fudge a little bit and not rewrite it. I'm just going to start plugging in values. A is 1,000. 1 plus X is 50. Next is over a C, which is 200. And B is to the power of negative 4. So that's all it asks me to do on part D. Part A is to substitute in the values. Part B says, according to the order of operations, which part of the equation do you evaluate first? Then do so, and then leave the answer as a fraction, leaving the answer as a fraction and writing your new equation. So order of operations, we do parentheses first. If we've got something with stuff inside, we do parentheses. Then we do exponents. Then we do multiplying and dividing left to right, and then we do adding and subtracting left to right. And we have some parenthesis work to take care of. So that means the parenthesis work needs to be taken care of. So I still have my 1,000. It is 1 plus something to the negative 4. So grabbing a calculator, reducing in your mind or on paper, we have 50 divided by 200, and that is a value of 25 hundredths. And it actually says leave your answer as a fraction and then write your new equation. So instead of 0.25, I was supposed to do this, and then 5 goes into 5, and 5 goes into 20. I was supposed to leave it as a fourth. Moving on to part C. Part C says, what is the next step in evaluating the expression? And that's according to order of operations. Do this, but leave the answer as a fraction, leaving the answer as a fraction and writing your new equation. So we took care of the inside parentheses work. Now we need to take care of an exponent. So I still have 1,000. I still have 1 plus. Now either using our 0.25 or using 1/4, we need to send it, one of them, to the negative 4th power. So hitting clear multiple times, I'm going to go ahead and send 0.25 up to the 4 negative power, and I get 256. It asks us to leave this alone and go on to part D. Part D says use the order of operations to evaluate the resulting equation. Show your work and round your answer to the nearest hundredth. And let's see if I've got some room below here. I have some more room. So I'm going to keep going. Aunt Sally says if you have stuff to multiply or divide, you should do that first. And adding and subtracting, you should do that next. Well, we also have to deal with this division bar, and that's going to be the last thing we do, kind of breaking the plane. So down here, I have something to add. So I'm going to have 1,000 over 257. And then approximately, rounding to the nearest hundredth, I am now kind of looping back around, but I'm done with adding and subtracting. And now I need to break this plane and actually do my division. So it's almost like there's a fifth step. Break the plane, do the division, and I get 1,000 divided by 257, round to the nearest hundredth, and I get 3 and 89 hundredths. So we just took maybe a somewhat scary looking formula, and it was no big deal. We plugged in the information and we took it one small step at a time, and we now have an answer for our y. Our y will be 3 and 89 hundredths. This concludes lesson 11C. Do go check your syllabus to see if you have more lessons to complete for this week before the deadline, and make sure you upload these by the deadline, and I'll see you in another lesson.